In this video, we're going to look at a couple examples of how we can apply the law of sines. So the law of sines says that the sine of any angle, and in particular we have L, M, and N, so the sine of a particular angle, L, is going to be equal to the side that it projects to. So we're going to call this side L, and that ratio is going to be exactly the same as the ratio of the sine of a particular angle, M, and the side that it projects to. And we can do the same, say the same for another angle, the other angle side relationship. So the sine of angle N and the side that it projects to. So what we want to find are a couple different lengths, Ln and Lm. So let's start with Ln. Let's start with Lm. So in order to find Lm, we're going to use this relationship that we know works, that we showed worked in class and prior to this. So I've got one angle side relationship right here. So I'm going to start with that. I know that the sine of the angle is going to be over the side that it projects to is going to be equal to the sine of another angle. So because we're finding Ln, we want to look at this angle that projects to it, so that's the sine of 39, over the side that it projects to. I labeled it little m, but really it's Ln. So we're solving for Ln. So here's the relationship, and this is just a proportion, so I can go ahead and cross multiply. There's that product, and then that's equal to the product of the other cross multiplication. And if I want to solve for Ln, I divide both sides by sine of 128. And what I come up with is something that I can plug into my calculator and figure out the exact value of Ln. So a little bit of calculator work, and I can come up with a rounded value for Ln. So I end up with Ln is equal to 19.979 or 19.98 about, and there's the answer for my first part. So let's go ahead and label that on here, 19.98. The next part I want to solve for Lm, so that's this piece over here. A little bit of work to do before then. I need to figure out what this angle is right here, angle N. So the measure of angle N is going to be equal to 180 minus the sum of these two. So the measure of angle N, the measure of angle N is equal to 13. 13 degrees. So now I can go ahead, I now have this is 13 degrees, and I can figure out my last side here. So let's go ahead and do that. The measure of angle N is 13 degrees, so the sine of 13 degrees over Lm, that's the side that it projects to, that's going to be equal to either one of these other ones. Now what I would say is we know exact values for this angle and this side. This is a rounded value. Anytime you can use exact values, you want to go ahead and do that. So the exact values come from this relationship, this side angle pair right here. So I've got the sine of 128 over 15. And I go through and solve just like we did last time. So I end up with 15 times the sine of 13 degrees equals Lm times the sine of 128. Divide by the sine of 128. A little bit of calculator work, and I get Lm is equal to about 4.28. So within that problem, you can see we use the law of sines twice in order to solve for those missing sides. And we just use those relationships. So let's check out a different kind of problem here. Again, we've got an angle-side relationship. And we want to end up trying to find the measure of angle Z. So that's this angle here. Well, the fact that we've got an angle-side relationship in one other piece allows us to use the law of sines. So let's go ahead and use it. So I want to find the measure of angle Z. So I know that the sine of Z over the side that it projects to, so that's 18, is equal to any other ratio of sine of an angle to the side. So we have one here, so let's go ahead and use that. So that's the sine of 79 over 27. So let's go through and solve. Remember, ultimately I'm trying to find the measure of angle Z. So I end up with the sine of Z. I'm going to multiply here in order to get the sine of Z by itself. So I get 18 sine of 79 over 27. And my next step here is to get Z by itself. So right now I have the sine of Z. I've got an expression for the sine of Z, but I need to get Z by itself. So I need to undo the sine function. And anytime we undo one of these trig functions, we use the inverse function. So if I take the inverse of both sides, that's going to undo that sine function, and that'll just leave me with measure of angle Z. And I took the inverse sine of this side, so I need to take the inverse sine of this side. A little bit of calculator work. Make sure you plug this in appropriately. Use parentheses whenever you can. And I end up with the measure of angle Z equals about 40.9 degrees. So again, we use the law of sines here in order to set up our relationship, and then from there it's just knowing how to undo these operations here. Isolate the sine of Z, and then in order to undo that function we have to take the inverse sine. Anytime we're solving for an angle, we need to use an inverse trig function.